Why not squared error? Why not squared error? We have our logistic regression model. It predicts probabilities using the sigmoid function. Now we need to train it. We need to find the best theta values. For linear regression, we use the squared error loss, the prediction minus the true value all squared. It seems natural to try the same thing here. For a single data point, the loss would be y minus sigma of x transpose theta all squared, where y is either 0 or 1, and sigma of x transpose theta is our predicted probability. When the prediction is close to the true label, this loss is small. When the prediction is far from the true label, this loss is large. Sounds reasonable, right? Let us see what happens when we actually plot this loss. Here is where things go wrong. In linear regression, the squared error loss was a nice bowl shape, a smooth convex curve with a single minimum at the bottom. No matter where you start, if you follow the slope downhill, you reach the minimum. But with logistic regression, we are squaring the difference between y and sigma of x transpose theta. The sigmoid function is nonlinear. It has that S-shaped curve. When you take a nonlinear function and compose it with the squared error, something bad happens. The resulting loss function is no longer convex. Instead of one clean bowl, the surface has bumps and dips. It can have multiple local minima, valleys that are not the deepest valley. The loss landscape becomes wavy and unpredictable. Why does this matter? Because we use gradient descent to find the best parameters. Gradient descent follows the slope downhill. If the surface has a single minimum, gradient descent will find it. But with multiple local minima, gradient descent can get stuck. Imagine you are blindfolded on a hilly landscape. You can only feel the slope under your feet. You walk downhill until you reach a flat spot. Is this the lowest point in the entire landscape? You have no way to know. You might be at the bottom of a small dip, while the true lowest point is far away on the other side of a hill. That is exactly what happens with the squared error loss for logistic regression. Gradient descent might converge to a local minimum that is not the global minimum. Different starting points can lead to different solutions. The result is unreliable. Sometimes you get a good model, sometimes you do not, and you cannot tell which is which. So where does this leave us? The squared error loss, which worked so well for linear regression, fails for logistic regression. The sigmoid nonlinearity makes the loss surface non-convex. Multiple local minima trap gradient descent. We need a different loss function, one that, when combined with the sigmoid, gives us a convex optimization problem, one with a single minimum that gradient descent can reliably find. That loss function exists. It is called the cross entropy loss or the log loss. And that is what we will derive next.